In number 12, we want to find all the vertical and horizontal asymptotes of this function. So first of all, the vertical asymptotes are going to be when the denominator equals 0 and the numerator does not. And here we're going to say 2x plus 5 equals 0 means x will be negative 5 halves, and that does not make the numerator 0. The square root of 3 or negative square root of 3 would, so that's not going to come into play in this problem. And then x equals negative 4. So vertical asymptotes will be x equals negative 5 halves and x equals negative 4. Horizontal asymptotes are simply end behavior, and the end behavior of this function, you got to be careful. You can't just take x squared and the 2x here because there's also another x here. So when you multiply the denominator together, the factors in the denominator together, you will end up with a 2x squared on the bottom and an x squared on top, and that's all you worry about is the highest degree terms. So x squareds will cancel and you'll be left with a half. So the horizontal asymptote will be y equals 1/2. Number 13, we have to find f inverse and give the domain of both f of x and f inverse of x. So first of all, the domain for f of x is going to be x greater than or equal to negative 2, because x plus 2 has to be greater than or equal to 0. The range will be y greater than or equal to 0, because it's a square root function, simply shifted 2 to the left. F inverse of x will be, well, to do that, we've got y equals the square root of x plus 2. The inverse, we flip-flop x and y, so x equals the square root of y plus 2. To solve for y, we're going to square both sides, and y will equal x squared minus 2. So f inverse of x is x squared minus 2, and the domain, a lot of people would make the mistake of saying the domain is all reals, but it's not. Remember, we have to base it back on the original function. The domain will be equal to what the range of the first function was before we took the inverse. So the domain will be x greater than or equal to 0, and the range will be y greater than or equal to negative 2. So basically, as you know, x squared minus 2 is a parabola, but it's only going to be the right half of the parabola is f inverse of x. And then f of x was the square root of x plus 2. So that was this. And you can see that, they are the inverses of each other. Number 14, we're asked to find f inverse of x and give the domain range. Again, same thing. So our domain is going to be all reals. X cannot equal negative 3. Our range, and this one's a little bit tougher because it is a piecewise function. I'm sorry, what did I just say that for? It is a rational function. Sorry about that. It's a rational function. And you're going to have a horizontal asymptote at y equals 2. So your range is going to be all reals. Y cannot equal 2. Let's go ahead and I'm not going to go through and graph that right now. But let's go ahead and find the inverse. So we've got y equals 2x minus 5 over x plus 3. The inverse is going to be x equals 2y minus 5 over y plus 3. X times y plus 3 equals 2y minus 5. xy plus 3x equals 2y minus 5. xy minus 2y equals negative 3x minus 5. And then we factor a y out and get x minus 2 equals negative 3x minus 5. And then y will equal negative 3x minus 5 over x minus 2. If you'd rather, you could say 3x plus 5 over 2 minus x. Doesn't really matter. But that is our new function. So f inverse of x equals negative 3x minus 5 over x minus 2. All right, now what's the domain? Well, the domain, again, is what the range of the original function was, and so that's going to be x cannot equal 2. The range will be what the domain of the original one, and that's going to be x cannot equal -3. And as you can see, we've got that -3x over x, and again, that would be -3, and that's where that horizontal asymptote is, and that's what we get for the range. So let's go ahead and do number 15, and then we'll pause. Find two implicitly defined functions for the given relation. So we have to solve for y, and 3x squared minus 25 will equal y squared. So y will equal, if you take the square root of both sides, plus or minus the square root of 3x squared minus 25. So my two implicitly defined functions, the first one is going to be y equals a positive square root of 3x squared minus 25. The second one is going to be y equals a negative square root of 3x squared minus 25. So the original is not a function, and so we have to use two implicitly defined functions if we want to write it in a function as a function. So there we have it.